This is a 3-1 to 3-2 review. Calculators are not allowed. Number 1. The question says, at what point on the graph of the curves is the tangent line parallel to the specified line? So we have to remember from our past courses that that word parallel means the same slope. And let's remember that in this class, slope is the same as the derivative. So in this particular case, what we're asking is whether the derivative of this is the same as the derivative of this. The slope of this is the same as the slope of this. So if we write down the derivative of the first one, I will get a 2/3 x. On the second one, I have several options available. I can go back to my old Algebra 1 and Algebra 2 techniques and just isolate y and then read the slope off, or I could take the derivative after I've isolated y. So let's start just by isolating y. I'll get a negative 24y equals a negative 6x plus a 48. Now if I divide by negative 24, that'll give me y equals a positive 1/4 x minus a 2. So we can either take the derivative and get y prime equals 1/4, or we can remember that y equals mx minus b, so my slope would be 1/4. Either way doesn't matter. Now we want the two things to be parallel, so that means we need this slope to equal this slope. So we write down 2/3 x equals 1/4, and then we solve for x. Cross multiply, multiply both sides by 3/2. We'll get 1/4 times 3/2, which is 3/8. Now the question is, what's the point on the curve? So we have found the x coordinate. To get the y coordinate, we need to plug that 3/8 into the function. So that would be a 1/3 times a 3/8 squared. That is a 3 on top and a 64 times 3, which I don't know off the top of my head. We get 12, carry 1, 192. So my point would be 3/8 and 3, 190. Oh, no, wait. I need to do that because I canceled the 3. So we just get a 64 on the bottom. Forgive me. 3/8 and 3/64. That one's part A. Okay, B and C work exactly the same way, so we'll go through those pretty quickly. B, we again need the derivative. That's going to be x to the 5th. And if I isolate y on the second equation, I'll have a negative 5 over 160 x plus 2 over 160. So now I need x to the 5th to equal negative 5 over 160. So let's reduce that negative 5 over 160. That's going to give me 32. So I'll get x to the 5th equals negative 1 over 32. So the 5th root of that is a negative 1/2. I've got the x coordinate is a negative 1/2. I plug that into the y. That will give me a 1/6 times a 1/2 negative to the 6th power. So that's a 1/6 times a negative 1 over 64. And that'll give me, positive 1. So 1 over 24, carry your 2, 38. So 1 over 384. Last part, C. Let's do it over here so we got room. We have y prime. The derivative of the first is 6x. If I isolate y on the second one, I'll get y equals a negative 3x plus a 16 divided by a negative 9. So again, we can see here that y prime is the slope of this is 1/3. We need these two to equal each other because the two curves need to be parallel. So 6x equals 1/3, x equals 1/18. So now to find the y coordinate that goes with it, I need to plug that 1/18 in. So 3 times 1/18 squared plus 5, I don't know what that is, but I'm assuming you can figure it out. So that's good enough.